Today we are going to look at the composition of unknown compounds. Composition stoichiometry is the study of mass relationships of elements in a compound, and percent composition is an example of this. Some compounds contain the same elements, however, the ratio of these elements can differ. If that ratio is different, it must be a different compound with different properties. So for example, H2O versus H2O2. The boiling point of H2O is 100 degrees and the boiling point of H2O2 is 150.2, vastly different. Water requires a lot of energy to decompose, whereas H2O2 will readily decompose at room temperature. Water is not toxic, H2O2 also is toxic. Other examples of elements that have compounds that have different ratios are carbon monoxide and carbon dioxide, vastly different compounds, and C6H12O6 are glucose, and methanol, CH3OH. Same elements, vastly different compounds. The law of definite proportion drives percent composition because it means that the composition of a compound does not depend on its source or how it was prepared. And it states that the elements in a compound are always present in the same proportions by mass. It was proposed by Joseph Proust in the late 18th century. After testing many samples of copper to carbonate, he determined that all samples always contain the same proportions of copper, carbon, and oxygen by mass. So what is percent composition? It is the percentage by mass of each element in a compound. The mass percent of an element in a compound is the mass of an element expressed as a percent of the total mass of the compound, or it's determined by the molar mass of the element divided by the molar mass of the compound, multiplied by 100. As seen in the following formulas. So there are two ways we will look at finding the percent composition. First method is to take the percent of an element is equal to the mass of an element over the mass of a sample times 100. That's one method. And the second method is percent of an element is equal to the molar mass of an element divided by the molar mass of the compound times 100. The mass units will cancel as a result of division, therefore there are no units, just like any time you find a percentage. So let's try a couple examples of this. Both methods we will use. So the first method, the first question says, calculating percent composition using mass data obtained in the lab. A compound with a mass of 48.72 grams is found to contain 32.69 grams of zinc and 16.03 grams of sulfur. What is the percentage composition of the compound? So we write down our givens. So the mass of the compound is equal to 48.72 grams. The mass of zinc is equal to 32.69 grams, and the mass of sulfur is equal to 16.03 grams. So we are asked to find, when it says what is the mass percentage of the compound, that means finding the elements in the compound, and we have zinc and sulfur. So we're finding the percent of zinc and the percent of sulfur. So percent of zinc is equal to the mass of zinc divided by the mass of the compound times 100, and it's equal to 32.69 grams divided by 48.72 grams times 100. Put that in my calculator. 67.10 equals 67.10%. Now I'll find the percent of sulfur is equal to the mass of sulfur divided by the mass of the compound. And it's equal to 16.03 grams divided by 48.72 grams times 100. And we'll just do that. 16.03 divided by 48.72. Oops, I think I forgot right there to put a decimal. Divided by 48.72 times 100. So 32.90%. So that's it. So therefore, the compound contains 67.10% zinc and 32.90% sulfur. Okay, and that's that one. Next question. Example 2 says, calculating percent composition from the chemical formula. Cinnamonaldehyde C9H8O is responsible for the characteristic odor of cinnamon. Determine the percentage composition of cinnamonaldehyde by calculating the mass percents of carbon, hydrogen, and oxygen. So in this case, we don't have any information except for that we know the compound. So we're going to find what percent of each element it is based on periodic table data. So first we need the molar mass of our compound. So C9H8O. So we've got 9 times carbon, which is 12.01 grams per mole, plus 8 times 1.01 grams per mole, plus 16.00 grams per mole, and that equals 132.17 grams per mole. So now we're going to find from this the percent carbon, percent hydrogen, and percent oxygen. I'm just going to make this a bit. So we need the molar mass of how much each one is in the compound. So the molar mass of carbon is equal to 9 times 12.01 grams per mole. So that's 108.09. So I can find what percent carbon is by saying percent carbon is equal to the molar mass of carbon divided by the molar mass of C9H8O, which is equal to 108, times 100, don't forget that. 108.09 grams per mole divided by the total mass of the compound, which was 132.17 grams per mole. Multiply that by 100. And that equals oh no, let's do that again. 108.09 divided by 132.17 times 100. So that's 81.78%. Okay, now I'll do the same for hydrogen and oxygen. So the molar mass of hydrogen is equal to 8 times 1.01, which will be 8.08 grams per mole, Now I'm going to find my percent hydrogen, which is the molar mass of hydrogen divided by the molar mass of C9H8O times 100. Which is equal to 8.08 grams per mole divided by 132.17 grams per mole times 100. Okay, and that is going to be 8.08 divided by 132.17 times 100. So 6.11%. And lastly, we have oxygen. I'm going to move this over here. So percent oxygen is equal to the molar mass of oxygen divided by the molar mass of C9H8O. And there's only one of them, so it's equal to 16 grams per mole divided by 132.1, oops, I forgot the times 100 again. 17 grams per mole times 100 equals 16 divided by 132.17 times 100, 12.10. Oh, actually 12.11. 12.11%. Okay, so we found all our percents. It's a good idea to put a nice little, around your answers always, put a nice little rectangle too. Helps us to find your answer. Percent O and percent H. Didn't leave a lot of room for that one. Okay, so therefore, the mass percents of C9H8O are 81.78% carbon, 6.11% hydrogen, and 12.11% oxygen. Okay, so that's two methods to find percent composition. So now it's time for you to practice, and instead of all the questions that are on the bottom of this page, I'm going to instead ask you to do, and you can do as many as you like for practice. Five, 6, 7 on page 288 is probably enough. Do as many as you like. You have the answers. 5, 6, 7. Okay. Do those 3. Okay. So please make sure you reach out if you have any questions, and take care and have a great day. Bye.